A solution is made by dissolving 75 grams of sucrose in 900 grams of water, 25 degrees. The vapor pressure above the water is 281.9 millimeter mercury. The vapor pressure of pure water is this. What's the activity of water in the solution, and what's the activity coefficient of water in the solution? All right, so let's just draw a picture of what's happening here. So what we have in down here is water and sucrose that we dissolve, so it's aqueous sucrose. And then up here what we have is just water. Sucrose does not have an appreciable vapor pressure, so the only vapor above here from the solution is water, not from sucrose. For this system, the activity of water will be the pressure of water. This is the activity of water in the solution. Will be the pressure of water above the solution, up here, divided by the pressure of pure water. Given in the problem, the pressure above the solution is 281.9 millimeter mercury, and the vapor pressure of pure water is 289.1. So the activity of water in the solution down here is 0.9751. So what is the activity of water in the solution? What is the activity coefficient of water in the solution? That's a little more challenging problem, but we know that the activity of water in the solution will be the activity coefficient of water in the solution times the mole fraction of water in the solution. So we can figure out what the mole fraction of water is in the solution. We know what the activity is of the solution, and we can compare those two. And if gamma is 1 and they're the same, the actual activity, then the activity coefficient is equal to 1. If they're different, then the activity coefficient is not equal to 1. All right, so let's go ahead and look for the mole fraction. So the mole fraction of water in the solution is equal to the number of moles of water in the solution divided by the number of moles of water in the solution plus the number of moles of sucrose. The number of moles of water in the solution, the mass of the water was given as 900 gram. The molar mass of water is 18.02 gram per mole. So this comes out to be 49.94 mole. That's how many moles of water. The number of moles of sucrose given in the problem, we had 75 grams of sucrose. We'll put 4 significant figures there. The molar mass of sucrose is 180.1 gram per mole. So the moles of sucrose in there is 0.4163 mole. So the mole fraction of water will be the number of moles of water divided by the total moles and the mole fraction of water. The actual mole fraction that you made up the solution is 9916. So that's the actual mole fraction. The activity here was 0.9751. So the activity coefficient of water is equal to the activity of water divided by the mole fraction of water. We have the activity of water. Here we have the mole fraction. Oh, look, it's different. So if the activity coefficient for 1 were 1, the activity of water should be the same as the mole fraction of water. It's not, so therefore the activity coefficient is not equal to 1. And we'll just calculate out what the activity coefficient of water is in that solution. That is the actual activity, 0.9751 divided by the mole fraction, 0.9916. So the activity coefficient of water is 0.9797. Not quite a ideal solution. The activity coefficient is less than 1, meaning that even though you have 0.996 mole fraction, the activity is less than that. So it's as if water is less active than you would expect for its mole fraction. So that's it for examples.